The M3 submachine gun was actually designed with the idea to be a disposable weapon, and when soldiers first got them, most wished they could throw them away immediately. However, there's something that kept it in American hands far longer than anyone ever planned for. And in this video, we're going to tell you the whole story of this anything but ordinary submachine gun. So, let's start by explaining what the problem was that led to this piece of work being created in the first place. The United States entered World War II with the Thompson submachine gun as its standard automatic shoulder weapon. Soldiers genuinely liked the Thompson. It was chambered in 45 ACP, delivered serious firepower, and felt like a real weapon in your hands. Well made and expensive. And that was the problem, actually. At the beginning of the war, the price to produce a single Thompson submachine gun was about $200. Doesn't sound like much until you translate it into today's rough equivalent of about $3,400, and then multiply this by a never-before-seen war of attrition where the outcome was decided by which country could sustain mass production and sustain the losses the longest. Having such an expensive weapon that you need to build in thousands isn't helping this issue when resources were stretched across aircraft, ship, tank production, and everything else needed in wartime. The US military first tried to solve this by simplifying the Thompson and bringing the cost down in the M1A1 version. But still, those expensive parts built from solid blocks of steel were taking too much time and money that couldn't be made much cheaper. They quite quickly realized that they would need something completely new if they wanted to cut those costs as dramatically as they needed. So, in 1941, US Army Ordnance was watching the submachine guns in Europe that other nations had, most notably the German MP-40 and the British Sten. And the Sten made an impression especially as it held the title of one of the cheapest and simplest guns produced in World War II. It didn't look anywhere near as impressive as the Thompson, looking like someone made it in a garage with scrap metal they had lying around. And well, this is somewhat true. Brits were facing all sorts of shortages during that time, so they had to make their submachine guns as cheaply as possible. They used absolutely no elegance whatsoever, but made it practical enough to work. Stamped sheet metal and crude welds made it cheap, quick, and easy to produce, and still work enough to fire the bullets that kill the enemy. So, the US Army soon started their program to come up with something similar of their own, based on this concept. Requirements were all sheet metal construction, around the familiar 45 ACP caliber, the same round the Thompson is chambered in, and designed for fast and inexpensive production with minimal machining. It should be fully automatic with a semi-auto option, fire some 500 rounds per minute, and be able to place 90% of shots fired from a standing position on a 6x6 foot target at 50 yards. Basically, it had to perform in firing and reliability at least as well as the Thompson, in theory. The semi-auto feature was soon abandoned as it seemed not necessary for such a weapon and to simplify the production further. And here's an interesting thing. During the development, there were conversion kits for the 9mm cartridge. The idea was that this way, resistance fighters in Nazi-occupied Europe could be supported with these submachine guns and could then use captured German ammunition. About 1,000 M3s were produced chambered in 9mm, and some 500 conversion kits were delivered to resistance fighters in occupied France and Belgium, with even adapters for Sten magazines. The problem for resistance fighters was that the sights remained adjusted for 45. So in 9mm, it shot well high above the aiming point. Another thing is that this weapon was originally intended as a disposable weapon. In theory, soldiers would use them until they broke and then throw them away and take another one or whatever. So, these first prototypes, designated T-20, were actually performing impressively, scoring 97 out of 100 rounds in accuracy trials and firing about 5,000 rounds with only 2 failures to feed. However, here's where the first thing got overlooked, despite being reported. Malfunctions were caused by the 30-round Sten-type magazine design. Here's the thing. The rounds were stored in double-column but single-feed configuration, which made the magazine notoriously difficult to load, especially when you got to the last few rounds and the spring inside was compressed. And the second problem is that it was more susceptible to jamming from mud, dust, and dirt than the staggered feed magazines the Thompson used. Despite these demonstrated deficiencies, no changes were made, as changing the magazine would delay production, and such things mattered more to people who never set foot on the battlefield, where soldiers would depend their lives on these weapons they were so desperately trying to make as cheap as possible. So, the M3 went into service with the magazine that would become the source of virtually every reliability complaint the weapon ever received. The T-20 was further refined and soon adopted in December 1942 as the M3 submachine gun. For those keeping track, there was actually an M2 submachine gun adopted very briefly during this period. It was never put into mass manufacture and was dropped as soon as the M3 became available. The Thompson was the M1, the M2 was a footnote nobody remembers, and the M3 became the gun that mattered, more or less. The M3 was built from plain sheet steel about 1.5 millimeters thick. The receiver was stamped in 2 halves and then seam welded together, with a seam running all the way around the circumference of the gun where these halves joined. Only the barrel, bolt, and firing mechanism were precision machined. Everything else was stamped, pressed, spot welded, or seam welded. The trigger guard was just a small tab of sheet metal. The welding throughout was functional, but not pretty. It just needed to be good enough to work. The barrel was cold swagged, the same manufacturing technique the British used for the Sten. Once in full production, the unit cost of an M3 was about $21 for a complete weapon. That's equivalent to roughly $273 in today's money. One source estimates the cost was even lower, around $15 per unit in some production runs. Whatever it is, it was significantly less than the Thompson, that's for sure. Now, as you probably know about that nickname, grease gun, if you take a look at the weapon and a mechanic's grease gun, you can clearly see why they called it that. It was also called plumber's nightmare and the cake decorator, but grease gun is the one that stuck. As for the rate of fire, it also changed compared to what the specifications asked for. The M3 fired at only 350 to 450 rounds per minute, one of the slowest cyclic rates of any submachine gun in the war. Most submachine guns of the era fired at 700 to 800 rounds per minute, or even higher. But at this slow rate of fire, trigger control was remarkably easy. Experienced shooters could fire single shots or controlled pairs without difficulty, even with the large 45 caliber cartridge. Effective range was expected to be up to 100 yards, although 50 yards was more realistic for combat conditions. We'll come to that. As for the safety, it was only in the form of a hinged ejection port dust cover, which when closed, blocked the bolt either in its forward or rear position and prevented the weapon from firing.
Now you killing. Close it up. No, you ain't.
However, the problem with this ingenious and extremely complicated design you've now seen is that the cover bent easily if dropped and would disable this high-tech safety feature. And if you think we're done with the sarcastic jokes and with simplification of this weapon, think again, because we haven't mentioned the cocking handle, or more specifically, the lack of it. The original M3 had a crank-type lever on the right side of the receiver. Like many other submachine guns, you'd pull it to cock the bolt. But it was also being made of cheap material that would easily bend or break in the field, so they did the most logical thing and removed it entirely. Instead, there was a recessed slot machined into the front of the bolt. You stick your finger in there and pull the bolt back by hand. That's it. But good luck doing this during fighting with your muddy, bloody hands, grabbing the hot bolt after you've fired several mags in full auto. Now, if you remember that we mentioned it being intended as a disposable weapon, well, the first major problem was that they changed their mind during the process. However, when the M3 arrived on the front lines, there were no spare parts and no weapon-specific tools available to soldiers. And who would say that such a cheaply built weapon would ever break in rough conditions of combat? This was later improvised in 1944 as the shortage of spare parts became obvious, to somewhat solve the issue and keep existing M3s operational. As for the stock, it was simple like the rest of the gun and could be telescoped to be shortened, which was good for tank crews and support troops as a secondary armament. The rear sight was a simple piece of sheet metal bent at 90 degrees and welded on the receiver, while the front sight was a simple blade. Both were fixed and calibrated to 100 yards. On early versions, the sights were also fragile and could easily bend if you dropped the gun or snagged onto something with them. Okay. So now, how did soldiers react once they got M3s in their hands for the first time? Based on everything you've seen so far, you can understand why the first reaction was not so positive. And, well, the second reaction as well. It looked cheap and crudely built, because that's exactly what it was. And if you compare it to the Thompson, you can comprehend the difference of what was supposed to be the new submachine gun to replace it. The combat debut actually came with paratroopers of the 82nd and 101st Airborne Divisions during the D-Day jumps in Normandy. As soldiers entered combat with their new submachine gun, all those issues we mentioned earlier started appearing, of course. Frustrating reports led to slightly improved models, like adding a guard for the release button to prevent the accidental magazine release that happens so often, improving the stock slightly, adding a modified ejector, and other small things. There was also the problem of accidental discharge if dropped, because the dust cover could open and the bolt, if hit with enough force, could travel back, but not enough to catch the sear. The return springs would then push it forward. It would pick up a round from the magazine and fire, as the firing pin was fixed on the bolt, so it could fire like this even if the trigger wasn't pressed. So, what can I say? Try not to drop your loaded grease gun on concrete. However, once the soldiers passed that initial aesthetic shock and began using the grease gun in combat, reliability wasn't as good as desired, but it wasn't too bad after all if you took care of it. The slower rate of fire made it easy to put burst exactly where they wanted, and the stopping power of the 45 ACP cartridge compared to the German and British 9mm was much appreciated in close quarters combat, where the M3 was expected to operate anyway. It was particularly issued to tank crews, truck drivers, and paratroopers, all of whom appreciated a weapon that was significantly lighter and came in a smaller package than the Thompson. Another thing that came in handy for Special Operations Forces was the suppressed version of the grease gun, which worked quite well with the already subsonic 45 ACP cartridge and was fairly quiet. A flash hider for night fighting was also adopted, although it wouldn't see combat in World War II, but would see use in Korea. And when we mention the Korean War, here the M3 would actually be the main submachine gun for US and South Korean forces, while Thompsons were ironically being used as one of the main weapons by the Communist forces. Now the grease gun was supposed to be replaced by the M14, which was intended to be that universal rifle that would combine all the traits of submachine guns, full-power rifles, carbines, and light machine guns into one weapon. But this didn't quite go as expected, as the M14 didn't really shine in practice and was retired as the rifle with the shortest frontline service in US military history. Instead, although mostly withdrawn not from service entirely but from frontline service, the M3 would linger also in the Vietnam War and, believe it or not, even into the Gulf War in the 1990s. American tankers in the Gulf War were actually still armed with grease guns. And even more fascinating is that Delta Force operators use suppressed M3s, and some like them more for this job than the MP5 because the grease gun was quieter. Their versions were also fitted with thumb safeties, which the standard military version never got. There were quite a few copies of the grease gun made by other nations in different calibers, and it served with Japanese tankers until 2011. Not a bad service life for a weapon that was intended as a disposable stopgap in World War II.